Hi, welcome to the lecture on Chapter 8, Expanding Wireless LANs and Wireless LAN Security. So in this case, in this chapter, we're going to look at, discuss how wireless bridges, repeaters can help expand some of the functionality of wireless LAN. In your home, you just got one access point, and you get the coverage you get. Well, what happens if you're going to cover the school's campus, where we've got 40 or 50 access points, and how do I make all that work? We'll look at how wireless controllers can help simplify some of this management, outline some of the design consideration you want to think about if you're designing a larger network, and discuss how maybe Wi-Fi Direct may make it easier to help secure devices and synchronize data. Also, we'll look at new developments in multimedia distribution and some security features and challenges for the 802.11 networks. So let's look at bridges and repeaters. So we'll kind of take a little bit different look, a little different type of equipment. But in this case, it's usually for only enterprise class, so it's only for businesses. Now, granted, does that stop you from putting a repeater? If you've got a large enough house or a large enough property that you want to be able to get access to your devices from way in the back 40 on your property, it may be something you want to look into. But a wireless bridge is used to interconnect wired and wireless networks between, in this case, campus, but two different buildings beyond the range. So if I look at maybe a 100-meter range of an access point, what happens if I want to cover more than that? It's an ideal solution. Bridge is a ideal solution for connecting remote sites when they're separated by different obstacles. Little large geographic area that you want to get rid of. And multiple bridges and antennas can be combined to help increase your throughput. So here's just an example of a wireless bridge. And I've got two buildings. They're geographically separated. And basically, what am I doing? I got a wireless network in building 1, connecting a physical connection to a wire, but I can't get to building 2 very easily. So then I've got some wireless where there's a point-to-point network, but instead of having an access point, I'm just going to go here, wireless. But as you can tell, this is what? Hardwired. So I've got maybe some wireless information in here. It's hardwired here, wireless again. So it kind of gives you a little combination of both wired and wireless to bridge those gaps. So they're transmitting. I can extend the, transmitting times. We talked about SIFS, I think last week, maybe the week before. I have trouble remembering. But it's making sure that I'm changing that gap timing so to allow the receiver enough time, because of my distance may be longer. So I still have to allow for just a little bit more delay in receiving that. Now, because bridge connections can be up to 16 miles. Now, if you go longer, you want to make sure your data rate's slower. So you just want to make sure that you check your specification of your bridge and definitely test it to make sure it's supporting the users and the applications you're running very well. Another product could be range extenders. They are also called repeaters. A wireless bridge, some access point wireless routers can be configured as repeaters to extend the coverage. Now, granted, as network designers, you need to be aware of, again, additional delay with the repeater. But it gives you a little bit different design than the bridge did. So you can actually put multiple devices in to cover it. So here you've got access point, and really all I'm doing is I got an access point, but somewhere, because to get to this last
router, this desktop's a little bit further away. This repeater is just going to boost the signal. So maybe got 100 meters, 100 meters here and 100 meters here. And I just can't get this access point to get that 200 meters. So now I'll have a device set up to be in the middle to split the difference, to kind of repeat, to resend that signal. Now, managing those devices can be difficult, especially you think about the campus where we have 40 or 50 of these. There's a product called wireless controller. And wireless controller kind of can incorporate most functions of the access point, but guess what? They have no radios. So I can control a lot of information, but I'm really not going to send any data. So I can connect multiple access points to it, either cable or some other connection, and be able to control features and of different access points, which then makes my access point control a little bit, or updating information, SSID, passwords, a little bit easier. So they're basically, wireless controllers are just simplified access point. They consist of the physical radio, but only with some of the different management controls. So they're used to control your wired area network controller. So it kind of, and then once you do the control, then it pushes the information out to the access points automatically. If an access point fails, the controller can configure to say, okay, I want to redirect, maybe adjust transmit power on nearby access point to cover that coverage hole that was left by the failed access point. Maybe it'll allow you to do quality of service features. It makes it easier to deploy wireless, especially voice over wire. So when you're thinking about how to design your wireless LAN network, especially an enterprise network, there's several things you want to do. The size of the campus, number of access points, what kind of security do you want? The same thing as you're doing with in probably your NET125 or NET126 classes, you remembered to be able to put in redundancy in your network. Well, the same things here. Cisco talks about core distribution and access layer. Same thing here when you're designing your network here. Is you've probably seen pictures like this in your NET125 class talking about the different core, the high speed network distribution layer, which just kind of I want to distribute it evenly across the devices, or the access layer says, how do I get into my network? So here you're seeing different configuration where you've got network switches and wireless controllers handling access points, and they're lightweight because there's no control. All they got the radios, or all they're doing is managing traffic, but they got no control characteristics, where your wireless controller is dealing with all of that. Now, other consideration is, are you going to have bridge connection between business? They're usually treated in the distribution layer. And you saw in the other diagram here, it shows an access layer using wireless controllers and this lightweight, access point, the LWAP, lightweight access point. We're only talking about voice and not doing anything else. The controller handling all the updates and security issues, but you can also do it from a cloud. Now, another thing out there is called Wi-Fi Direct. Wi-Fi Direct, it's a Wi-Fi Alliance specification to make it simpler for end users to share printers, files, synchronize devices, play network games. You connect these by, and I've got one on my router at home to be able to press a device to get that near field communication set up. So it makes it easier to set up different devices.
Now, what happens if I've got wireless LANs and multimedia? And there's a couple of different systems out there, or protocols. And it may be that 802.11ad standard might help with that. 802.11c it says, hey, I want to start getting 6 gigahertz band as far as spectrum, allow bigger frames to get transmitted, handle contention access a little bit better, maybe guarantee some time slots for audio and video. Lets me do a little bit of different types of transmission, with how do I use beamforming and stuff. But it's kind of trying to support, it's trying to aggregate the frames, how to get them all together to support more throughput. Because we're talking if we're talking video data, we want to get up into the landline speed range. Some of these future protocols help. Wireless HD specification transmits video and audio in the 60 gigahertz band, but it has a short range. So I can do high def, but I got a shorter range. There's another protocol, wireless home digital interface. Utilize the 5 gigahertz band, but can transmit, 1080p compatible television signals from different range. Now, again, my range is not as great, but I'm getting the high quality that we would come to expect. Now, we're building all this network. We got all those things. What do I got to do? I got to make sure. What's the biggest issue with wireless has been security. Definitely when 802.11 first came out, security was one of the things that they forgot to put in. And I really do think it was such a cool idea that they just forgot to put security in, or they didn't think anybody would, break in. But, so now we're going to look at, now that I'm sending traffic, I've got to kind of bring up the same problems we've had with Ethernet. I've got to make sure that security on a wireless LAN, because now when you want to tap into your Ethernet, you got to actually have physical access to the cable. Wirelessly, I don't have that media to kind of isolate a little bit. I'm wide open. So now I've got to offer a different way of securing my data. So it allows, 802.11 allows a different security and we do it through encryption. Now, another thing is we got to make sure we get authenticated. I got to make sure, hopefully in looking at some of the assignments when you did your war driving, I think I only found like 2 or 3 systems out there that had no security on it, and a lot of the ones that didn't were actually printers. But back when I first did it in 2008-9, there were like 60% of the networks were unsecured. Well, authentication allows me to set a password to prevent access to the wireless LAN or the wired network, where it could be either a BSS or an ESS. It basically says I want to configure on a per SSID, which device do I want to get to. Now, the administrator can choose not to broadcast or hide the SSID in the beacon frames. Now, data privacy basically ensures that nobody can read it that isn't supposed to. Data encryption basically scrambles in codes, just like you did when you were in grade school, wrote your own code to kind of make sure you pass notes to each other that nobody can read other than the people that created the code and understood it. So basically, the strength of encryption says I need to keep the keys secret and the length of the keys
The longer they are, the better the encryption. So guess what? And part of the stuff when you did your war driving, you saw different securities out there. Well, one of them is WEP, Wired Equivalent Privacy, WEP. It's a data encryption spec. It had two versions, 64 and 128 bits. Trouble is, even the 128-bit keys could be decrypted in minutes because it uses a very weak implementation of RC4. You very rarely, hopefully in your war driving, you didn't find any of this. But you may have, if based on the neighborhood. Now, the next one is WPA, Wi-Fi protected. It's a standard encryption. It was Wi-Fi Alliance's response to the weakness in WEP. It uses a 128-bit pre-shared key, a PSK. So usually you'll see WPA PSK as as how it's defined. Now it uses a different encryption key for each device, for each packet, for each session. So it's changing this encryption key a lot. Now, WPA employed a temporal key integrated integrity protocol, TKIP, which says I got per packet key mixing. Plus it also gets integrity checks. It gets, it has a 48-bit hash, an algorithm. Guess what? That still wasn't enough. So now you end up having WPA2. It's much stronger encryption to WPA, certified by IEEE, compatible with the 802.11i standards. It supports an advanced encryption standard, AES, but it doesn't use TKIP. Now, when you're looking at 802.11i, but they also says, hey, I need something even more robust. So you're getting IEEE come up with two security standards, I and 1X, to define a robust secure network association. So to make sure I got authentications between client devices and APs, control access to the network, different types of security keys, and how do I manage those keys? Now, 802.11i, a client device must be authenticated on a network by an external authentication service, whether it's Raidus or by the access point itself, but it's got to be external. So whichever way it does, in a lot of cases, you at least with the ones at home, if you've got this on your network, it's probably done with the access point itself, but it could be an outside authentication server. Now, when you're using this external authentication service, all communication between the device and the AP is blocked. It's blocked until what? Until you're authenticated. Now, 802.1x uses a different protocol, EAP, extensionable, how do you pronounce that? Authentication protocol, for relaying access between the wireless device, AP, and the radio server. So just now, how do I communicate with that device? Now, some of you that have newer devices, you probably have a push button, security system. It allows you to, press a button to give you security, which allows you to access. So basically it means I need to be able to change security, add people to my devices, add devices to my network. But both your network interface card and your access point must support this feature. It's kind of cool. It makes setting up new devices, new networks relatively simple. Now, you've heard about virtual private networks. It basically is just a tunnel between 2 points. It basically means that they're definitely strong encryption, like AES, and it's probably the one of the most secure methods of implementing wireless network. But it's pretty much a point-to-point security. You can got site-to-site VPNs, maybe a client-to-site VPN, especially when if you're going to be on a lot of private. When I was on the road a lot, I would use client-to-site because I didn't know where I was going to be. So I was only coming from a public network, and I needed to make sure that I can implement some kind of security between my computer and the one in the home office to make sure that happens. And here's just a couple of pictures of two different sites, where it's client to site or site to site. Now, there's two other ways you can do this. I can detect intrusion, or I can prevent intrusion. Now, if I'm preventing it, it's usually a standalone wireless device or a feature in some of the more advanced APs that's just kind of monitoring the RF spectrum, and it detects if somebody's unauthorized. Now, intrusion detection basically says, hey, I'm going to notify system administrators when an intrusion is happening. And then the administrator, can locate, remove, whatever they want to do based on their security policy, what their job is to correct that. Now, some of the other things that you can think about is I can reduce the transmission power. Just because you have an access point that can transmit up to 300 feet or larger doesn't mean you have to. You can reduce that power to the point where it's just barely getting through your walls. So you just want to change the power, transmission power to change that coverage area to match the service that you want to provide. Now I can change the default security systems. I can make sure I've included anti-virus, anti-spyware. I can separate wireless LAN from wired network traffic. I can put a firewall between them. Different things you can do. Now, what are some of the attacks against wireless LAN? Well, some of the more dangerous ones is hardware theft. Basically breaking in, I want to prevent anybody breaking in and taking my access point or getting the data. I want to make sure that I don't have a rogue AP, somebody impersonating a valid device. Or I don't want somebody just passively just monitoring all the data that's going on and gathering what information is being sent. Of course, I also don't want somebody denying service, basically flooding my network with transmissions that would deny valid users from getting access to the network. Now, one of the things you can do, and you can probably do this on your home, is I can set up MAC filters to enhance the security. I can go in and say, which MAC addresses will I allow on my network? So when somebody comes in and registers on your computer, you just got to say, hey, what's your MAC address? Input that into the system, and says that way you're one of the listed of valid devices that can get access to my network. Now, granted, it on one hand, it sounds like it's really, really good when you say, hey, MAC addresses, they're limited, they're restricted, but they're not that long. So they can be spoofed. And there's tools out there that'll actually allow you to change MAC addresses. So some things you want to think about here. So to keep in mind, so extending the network, you got bridges, you can do range extenders, repeaters, wireless controllers. If you have multiple APs you need to control, they're usually deployed at the access layer. You got some different ways of handling connection between two devices, dedicated technologies and standards that are out there for security. You got data privacy, WPS, intrusion detections. So there's a lot of different ways of extending your wireless LAN and improving the quality and the security of your wireless network. But as the wireless network designer you are, you'll make the best choices with this information that I've given you. If you have any questions, let me know.